Hello, I am audible. Please, Manishwa, please confirm me. Just one. Or you can write in the chat box also whether I am audible or not, or slide is visible or not. You just both thing is confirm, please. So just please confirm whether I am audible or not. Please confirm me just once whether I am audible or not. Okay, okay. And slide is visible. Assignment 5, fluid mechanics. Okay, today is the week number 5, so we'll solve the assignment number 5 of the previous NPTEL questions. So we'll wait 5 minutes for other participant. Maybe other participant will join. So let us wait for 5 minutes. So now we'll start. So whether I think I'm audible. So welcome all in week number 5. I'm Om Prakash Maurya. So we'll solve the question number 1. So question 1 is about, let me just read for another student. Okay. So assignment number 5. Question number 1. Consider a 1.7 meter tall man standing vertically in a water and completely submerged in a pool. Determine the difference between the pressure acting at the head and at the toes of this man in kilopascal. Consider the depth between the top of head of the man and the free surface of the water negligible. So which option will be correct? Just please try to solve, then I will explain what is the concept and how you will draw the diagram and how you will solve. So first of all, I need answer from your side in the chat box. So which option will be correct, please? Just write in the chat box. I am waiting. You have 5 minutes or 3 minutes you can take. So please anybody, if you want to write your answer, you can write, otherwise I will show you how you will calculate. So let me show you. So the question is about the consider a 1.7 meter tall man standing vertically in water. So I can consider one man is there. You can consider here one man like that. He is standing, okay, in water. So total height is 1.7. Completely submerged, yes, I have put it. Determine the difference between pressure acting at the head, pressure at head, and the pressure at toes. So here, pressure at toe in kilopascal. You need to calculate in kilopascal. Consider the depth between the top and head of the man of the free surface is negligible, very less. So negligible. Here the depth is negligible. So how you will calculate? If depth is negligible, your hydrostatic pressure will be negligible. This will be your negligible. Okay. So how you will calculate? Just you will put here your hydrostatic concept. Rho GH 1000 into 9.81 into your 1.7. For easy calculation, if I put 9.81 as a 10, 1.7, so it will come around like that. 70,000, 17,000 it will come. So in kilopascal you can write 17 kilopascal. So here you have converted 9.81 in 10. So your answer, actual answer will be little bit less than 17, right? So it may be not exact 17. So you can write this one. Option C may be correct if I am not wrong. Yes, option C is correct. You can see here. So asking difference. So if you will calculate the difference, so what will be happen? Pressure at toe minus pressure at your head. So it will be 0 at head. So definitely your pressure difference only toe, because negligible in question is given already. Now we'll move ahead on the question number 2. Which of the following assumption is incorrect in the derivation of Bernoulli's equation? Flow is rotational, flow is ideal, flow is steady, and flow is incompressible. So I need answer from your side for this question, because this is very easy question. So please try to give your answer in the chat box. Okay. Kedar is telling option A. Okay. Other student, please also you try to write in the chat box. What is your view on question number 2? Whether option A and B, C, D, which one will be correct? Okay. Simranjit is also telling option A. Another student, if you want to you write your answer, you just write in the chat box. You just remember, just refresh your mind and try to remember the assumption behind the Bernoulli's equation, and after that you will give the correct answer. Okay, so I think we'll move on the next question. So option A, yes, option A is correct for this second number question. Now we will move ahead on the next question. Next question is about the water pressure in the main. Next question, the water pressure in the main pipe of a city at a particular location is 270 kilopascal. 270 kilopascal gauge. Determine if this main can serve water to neighborhoods that are 28 meter above this location. So you need to find out at a particular location pressure is 270 kilopascal in gauge pressure. So let's suppose a house is look, the house location is 28 meter above your the pressure location where you have measured 270. So whether this much pressure is possible or not to uh, transport the water from your 270 kilopascal location to 28 meters, or convey the water from this location to this location. So if your pipe, let's suppose here, going outside also, water is, you measured here your pressure, so it is showing 270, and one house is here, this side, this is 28 meter, or here is a tank, so the tank height is, if you will measure here, 28 meter. So whether this much pressure, whether this pipe is possible to reach the water at this tank or not, this question is like that, yes or no, but you need to calculate, then after you put your answer whether it will be able to reach or not. So please just you try to calculate, then you try to give your answer. Question number third. Okay, Kedar is telling yes. Okay, another student, please also try to give your answer. Okay, Simranjit is also telling yes. Another student, please. Or you can write A and B also. Okay, Vijay is telling no. Okay, okay. Other student, please. You have 1 minute more for this question. Another student, please also you can put your view in the chat box, whether it will be A and B, yes or no. Vijay is telling the 27.52 meter. Okay. Pressure at, I think at house level, pressure is 27.52. Okay, I will see what actually you are telling. Okay, now I want to explain. So basically your pressure is equal to, what is your pressure? Here you have 1 unit in meter, so you need to convert this 270 pressure in terms of meter. So how you will convert? Pressure is equal to rho gh, so 1000 into 9.81 into h. P is equal to 270 kilopascal, so you will multiply power 3. So h is equal to 270 divided by 9.81. So how much it will come? It will come, let me move below, 27.5. 27.5 means 270 kilopascal pressure having potential to reach up to 227.5 meter. Even if your house at the level of 27.6 meter, this much pressure is not able to convey the water from this location to your house level. So here is 28 meter. So definitely not possible with this pressure. You need to increase the pressure. How much minimum pressure required? If anybody want to calculate, just my second question in this, what is the minimum? What is the minimum pressure required to convey the water at house level? So this is the question. You just please try to calculate. I need the minimum pressure. Just to write your answer in the chat box. Anybody, if you want to calculate, write in the chat box your answer. Definitely it will be more than 270. So if in your calculation your value is coming less than 270 kilopascal, then you wrong. It should be more than 270. How much? Just you calculate please and write your answer in the chat box. The minimum pressure required. Let me calculate first. Then I will show you answer. Okay. Okay. Visa is telling 274.68. Okay. Another student, please also try to write. Or if you are not able to understand, please just in the chat box you write. Please repeat the concept, or you can write in your own way. If you have any doubt, please you ask in the chat box, or you can use your mic also. Okay, other student, please also you write your answer. You can also calculate. If you're not having calculator, you can also calculate using your mobile. Because if you will not try here, because here is under pressure, you are sitting in your best place or comfortable place without pressure. If you will not try here, then in exam hall it will be very difficult. So I will give you 1 minute more. Please try to calculate and write your answer in the chat box. It is very easy. If you will think about my previous solution part, then you can easily write. You can easily calculate. Okay. Now I will explain. So the minimum pressure is nothing here. How you will calculate? Just simple rho gh. P minimum is equal to rho gh. So 1000 into 9.81 into h is equal to how much? 28. So when you will calculate, it will come around 7. I think let me just see the calculation. 274680. 274680 Pascal. So in kilopascal, 274.68 kilopascal. I think Vijay answer is correct. Let me just see. Yeah, 274.68 kilopascal. Yes, Vijay, your answer is correct. So now we'll move ahead on the next question. Please, other student also try to participate in the question answer session. Otherwise, it is basically it will be difficult to solve such type of questions in the final examination. So now the next question is the difference in mercury level. The difference in mercury level, the density of mercury is given 13600 kg per meter cube. The difference in mercury level of a pitot static tube connected to a submarine is 25 centimeter. Assume the coefficient of velocity CV is given 0.97. What will be the speed of submarine if the specific gravity of seawater is specific gravity of seawater? How much? 1.019. It is given already. So you need to calculate what will be the speed of submarine. So you need to calculate velocity. Just please try to calculate for question number 4. So you have 5 minutes. Within 5 minutes, you please try to calculate. So just use your mind how you will approach this question. the difference in mercury level in a pitot static tube connected to a submarine is 25 centimeter. So how you will calculate your head if the difference is given? Using the difference, how you will calculate the head? In last week, that is week number 4, we have discussed about this. So if anybody attempt the question number, not exactly I know the question number, but in the previous week, so you will definitely you are able to solve this question. Otherwise, little bit difficult, not that much. Okay, within 1 minute, you please write your answer. Otherwise, I will show the answer how you will solve. Okay, let me show you. So how you will solve? Your difference is given, x is equal to 0.25 centimeter is given. Then how you will calculate the head? You know already, rho hg divided by rho h2o minus 1. So here you can calculate h. Now you will, how you will calculate velocity? Cv into 2gh. So just I have given hint. If anybody want to solve, I can give again 2 minutes for that. So if anybody want to solve, you can attempt. Again I am giving the 2 minutes. So please try to calculate. Okay, please just because I have already given you hint how we will calculate. So you can calculate. Okay, let me show you. So your answer will come 7.55. So how you will calculate H? 0.25 divided by rho is given 13600. So if you will put here 13600 and rho of your sea water, it will 019, because you will multiply the specific gravity with the density of water. So now H is equal to, you will get, let me show you the answer. H is equal to, you will get 0.3.086 meter. So you will apply this formula, Cv is equal to 2gh. So you can get easily the answer. Now moving ahead with the next question. Next question is, a 150 diameter jet of water is discharged from a nozzle into the air at a velocity of 36 meter per second. What is the total head value with respect to a datum of groundwater? You need to calculate the total head here. With respect to datum at the ground level, if the jet is located 2.5 meter above the ground level. Okay. So you please try to calculate, then I will show you answer how you will calculate. So here you need to calculate in this question total head. Velocity is given 36 meter per second. Diameter of jet is given 150 meter per second, 150 mm. And the datum you need to consider the ground level, and your jet is located 2.5 meter above the ground level. So how you will calculate? So this is a very easy question if you know the concept and all. So please try to solve. You have again 5 minutes for this question. Okay, Simranjit is telling option B. Okay, we'll see whether we will correct or other. Other student, please also try to give your answer. Other student, please try to give your answer. Okay, I am giving you a hint. You will apply here the Bernoulli's equation. That is P by rho z plus V square by 2z plus Z. So this is the value of total head. Now you please try to calculate. Okay, Kedarnath is also telling B. Okay. Now I want to show you the calculation part also. So here your total head is equal to nothing but P by rho z plus V square by 2z plus Z. So in question actually written total head value with respect to a datum, one nozzle, let's suppose you have one nozzle here. Oh, this is the water jet. Okay, water jet is going up. So diameter of the jet is your diameter of jet. If I talk here, it is given 150. Okay, velocity is given air, in air, your whatever the velocity of jet in air 36. So air means what? Your gauge pressure will be 0 if you are going to calculate in air. So now the jet is available at 2.5 meter here. This height is 2.5 meter above. So z is equal to given 2.5 meter. V square by 2z you calculate, that is your 36 square divided by 2 into 9.81. Let me calculate. So it will come 36 into 36, 1296 divided by 2 into 9.81 divided by 2 divided by 9.81. So it will come 66.055, or you need to calculate, you need to add 2.5 plus 2.5. It will come, let me write here, this will be 0, this will be 65.055 plus 2.5. So your total head value will be 68.555 meter. So this will be the correct answer. Which one? Option B. Option B will be correct. Now we'll move ahead on the next question. Next question is about a liquid of specific gravity 1.3 flow in pipe at a rate of 800 liter per second from point 1 to point 2, which is 1 meter above point 1. The diameter at section 1 and 2 are 0.6 meter and 0.3 meter respectively. The diameters at section 1 and 2 are 0.6 meter and 0.3 meter respectively. If the pressure at section 1 is 1 bar, determine the pressure at section 2. So pressure at section 2 means if I write P2, then you need to calculate the P2. So here you have again 5 minutes. So you please try to calculate. Here again, just you please try to calculate, then I will give you some hint. But firstly, you need your approach. You apply your approach. Oh, after this question, maybe you can take 5 minute break. Then we'll move ahead. Just please try to solve this question first. Then we'll move. Go for back. This question is a little bit calculative nature, so please try to calculate. This type of question I think you can see in the GATE examination also. Lots of questions based on this concept in previous year GATE examination I am talking. So please try to solve. So actually you will apply here the Bernoulli equation. So let me draw the what is telling the question, then you can easily I think get. So a liquid of a specific gravity 1.7 1.3 flow in a pipe at a rate of 800 liter per second from point 1 to point 2, which is 1 meter above the point 1. From point 1 to point 2, which is 1 meter above the point 1. So your point is like that. So this is the, if you will consider datum here, at dot dot line I want to consider the dot datum here, datum. So this height is 1 meter. Okay, here your z is equal to 0, here z is equal to 1. This is section 2, this is section 1. So I need to write here, or you need to also write z1, z2. Pressure at section 1 is given P1 10 bar. Pressure at section 2 you need to calculate. Okay. The diameter, okay, diameter is varying I think. The diameter at section 1 and section 2, here diameter is okay 0.6 meter. Here diameter is 0.3 meter. D2 is given 0.3 meter. And your discharge is given here, Q is equal to 800 liter per second. So 0.8 meter cube per second. So from here you can calculate your velocity V1 and V2. So here diagram little bit modified. This side your dimension will be more compared to this side. Okay. So for time mean, let us consider like that. No problem. So your velocity is equal to what? Discharge by area A1, discharge by A2. So 0.8 divided by area pi by 4 into d square means 0.6 square. Here 0.8 into pi by 4 into 0.3 square. 0.3 square. So you will calculate, let's suppose your value is come x and here your value is come y. So what you will do, you will put here your write your Bernoulli's equation at section 1. P1 by rho z plus V1 square by 2z plus Z1 is equal to P2 square by rho z plus V2 square by 2z plus Z2. So Z1 value is given, Z2 value Z2. You know already the velocity already. P1 value already know. How much given? 10 bar. 10 bar means how much? 10 into 10 to the power 5 Newton per meter square, or you can say Pascal. Right. So now you have every data. So you can calculate very easily pressure value. Then you need to divide by 10 to the power 5. When you will divide, your pressure value come in the bar. So let me show you the answer. How you will calculate? The answer will be your 0 point or 9.092 bar. So how you will calculate? Like that. Like that you will calculate your diameter like that. This side will be more, this side will be less. So from here you just see the datum things. So HL is 0 here because of the I think data is not given, so we can consider in such type of question the head loss will due to the measure due to the friction will be 0 or negligible, you can consider. Next question is the maximum blood pressure in the upper arm of a healthy person is about 120 mmHg, that is gauge pressure. If a vertical tube empty, if a vertical tube empty open to atmosphere is connected to the vein in the arm of a person, determine how high the blood will rise in the tube. Take the density of the blood to be 1020 kg per meter cube. So this is the question. You can solve this question. So I need 5-minute break. If anybody want to take 5-minute break, you can take. So please try to, in meantime, you if you want to solve, you can solve. Okay, Vijay Kumar is telling the option number D. Okay, we'll see. Let me read question once for other students. The maximum blood pressure in a upper arm, here maximum blood pressure in upper arm of a healthy person is about 120 mmHg. That is gauge pressure here given. Pressure in the upper arm is given 120 for a healthy person. Okay. If a vertical tube, if a vertical tube open to atmosphere is connected to the vein in the arm of a person. Let's suppose a tube is connected in the arm. Here is given in the figure, you can see here. Now determine how high the blood will rise in the tube. So here you need to calculate rise of height. So you can height rise in the tube. You need to calculate. Take the density of blood is given. Rho of blood is given 1020 kg per meter cube. So pressure mm of Hg means what? mmHg is given how much? 120 mmHg. So how you will convert in the Pascal and all, or Newton per meter square? So 120. Anybody want to say something? Okay. So how you will calculate your pressure in terms of your normal, in that is Pascal. So after converting in Pascal, your pressure will be equal to rho of blood into G into 1 point, or you need to write here your height. So height you will calculate what? Your pressure rho Z. So with this formula you can, with this concept you can very easily calculate. So how you will move? Let me show you. So how you will convert these things? So basically you will convert like your 120. First you will convert this 120 in meter, because Newton per meter square you need. So 120 into 10 to the power minus 3 and rho Z here given. That is your in form of mercury. So you need to put here the mercury density, okay, into 1000 into 9.81. So this is the pressure. How much? 16010 Pascal. This is the pressure. And now when we will put this pressure in form of, in this equation, your 1020 I think into Z is equal to 9.81. So you will get how much? 1.660 meter. This is the maximum value. So now the next question is question number 9. A metal plate 1.25 meter into 1.25 meter into 6 meter thick and weighing 90 Newton is placed midway in the 24 gap between the two vertical plane surface, two between, you just see here, the gap is filled with an oil of specific gravity 0.85. Whatever the gap is given here, it is filled by the your oil with a specific gravity 0.85, this gap, this much gap. Okay, and now the dynamic viscosity is given 3.0 Newton second per meter square. Determine the velocity at which the central plate will move. Okay, so you need to calculate your velocity. Determine the velocity at which the central plate will move. So here you need to calculate your velocity like that. So whatever the velocity will be, oh, this will come here. So you need to calculate your velocity. So you please apply your concept or brain whatever you have learned last previous chapters or last previous NPTEL lectures, so you can easily calculate. So for this question you can take 10 minutes, no problem, because this is a big question, little bit calculative also. So 10 minutes you can take for this. Everyone please try to calculate. So I want to give you hint little bit in this question. So how you will calculate? So in this question you will apply you formula like tau is equal to mu du by dy, right? So thickness is very less. So this thickness is very less. So what you will do? Tau is equal to mu into velocity divided by depth. So this formula you will apply. So this much hint for this question. Now please try to calculate. You have more 3 minutes. Within 3 minutes, please try to calculate. Okay, Kedarnag is telling option B. Okay, good. Other student, please. Other student, please also try to participate. Last 1 minute, please. You try to give your answer if you have already calculated. If anybody need more time, you can write in the box. Then I can wait. Otherwise, I will show you answer. Okay, let me show you answer. So what actually here you will do, let me first discuss the concept. So your plate volume actually is given, your plate is like that, this much. The plate is like that. This is given, this width is given your 1.25 and this is also given 1.25. So okay, now I have tell you already, you will use this formula. Why? Because this gap is very less. So your tau is equal to what? Force divided by, or you can say the tangential force divided by area. So area what? This much area. The plate this much area. So area is 1.25 into 1.25. So it will become around 1.5. Let me just, I have already calculated. So I want to see 1.25625 meter square, right? F is given already 90. So you can put here your F, that is 90 divided by 1.5625 plus equal to, mu value is already given 0 point or 3.0. So okay, now this side oil, this side, both side is oil, and if you will see here, this both side will try to move the your plate. So you need to consider both side. For what? For your this your velocity and the depth, or your the depth between. Depth means here what? This much depth. That is T1, T2 is already given. So this much. So you need to calculate U, and T1 is given how much? Okay, how you will calculate? The 20 mm gap between the two vertical plate, the gap is 20 mm. So T is equal to, or T1 is equal to, what you will do? If the both side is equal, so half into 24, oh sorry, 20, not able to write. So T1 is equal to half 24 minus, why this is like 24 minus 0 point, or you can write 6, because what? 6 mm thickness. So it will become around 9. Why it is not? So after that, what you will do? Just you will U divided by your thickness. Thickness is T1, that is 9 mm. 9 into, oh, why it is like that? Oh, 9 into 10 to the power minus 3 plus. Why minus 3? Because it is mm. For another, for T2, U divided by 9 into 10 to the power minus 3. When you will calculate, you will get U is equal to how much? Let me show you. 0.15. So you will get 0.15 meter per second u value. So this is the correct answer for this question. You can expect such kind of a question in the examination. So now we'll move ahead. Question number 10. So question 10 is about underground water is to be pumped by a 70% efficient 5 kilowatt submerged pump to a pool whose free surface is 30 meter above the groundwater level, and in figure you can see, and the diameter of the smooth pipe is 7 centimeter on the intake side and 5 centimeter on the discharge side. Determine first the maximum flow rate of water, second the pressure difference across the pump. Assume the elevation difference between the pump inlet and the outlet and the effect of the kinetic energy correction factor to be negligible. Hint what is hint given? The Bernoulli's equation applicable. So which option will be correct? Option A, B, C, D, which one? So please try to calculate. For this question you have also 5 or 5 minute, or you can take the 8 minute also, no problem. Oh sorry. So please try to question number 10. So in this question you need to calculate what? No, in first option A, let me just show you. In option A, you need to calculate maximum rate of water. So this is the maximum value you need to calculate. And in the second part, in the B part, you need to calculate the pressure difference across the pump. So how you will approach this question? So let me just show you the answer. Okay, so it is not working very well. So maximum flow rate, you know the already the energy, how you will calculate the energy. So because why we are using here energy? In question already given the 5. So here is the 5 kilowatt sum was already given or 70% efficiency. So energy is given already. So here energy is equal to what? Rho Q GH. So energy is 5 kilowatt. So 5 into 10 to the power 3 and 70%. So 0.7. That is 770 by 100. So it will come 0.7 equal to 100,000 into Q value you need to calculate 9.81 into 30. So you will get Q is equal to 0.0119 meter cube per second. So here option A, maybe option B, which will be correct. We'll see when we'll calculate your second part, the pressure difference. So how you will calculate the pressure difference? Pressure difference at exit minus pressure difference at inlet. So area is different at both exit and inlet. Let me show you. So I don't know why it is running slow. So here is area, that is the diameter of the smooth pipe is 7 centimeter on intake side. Here is diameter is 7 centimeter, and 5, that is the discharge side. This side is 5 centimeter. So definitely your velocity will be different. So because when you will apply your Bernoulli's equation, so P by rho z things will come. So P is here and rho z these things, that is 1000 into 9.81. Now V2, let me write, then you can very easily understand. So P1 by rho z plus V1 square by 2z plus Z1 equal to P2 square by rho z plus V2 square plus G 2z plus Z2. So if you will consider the Z1, that is datum at level of 1, so Z1 will be 0 and Z2 value will be there. So you need to calculate P1 minus P2. P1 minus P2. So what you will do? This entire thing will go this side and P2 will come this side. And rho z, whatever the remaining rho z. So this is rho z into V2 square by 2z plus Z2 minus V1 square by 2z. So that thing is written here. V2 inlet and exit your V square by 2z. So just you will put your for whatever you have got the discharge. So discharge is 0.9 and area is pi by 4 into d square, means 0.7 square. You will get velocity like that. And when you will calculate your velocity at exit, so you need to put 0.05, you will get this much. So pressure at exit and inlet, or you can say here the P1 minus P2. So 1000 into 9.81 plus V1, so 3.0 9 square divided by 2 into 9.81 plus Z2 is already given 30 and 6.06 divided by 2 into 9.81. So here minus, not positive. So after calculating you will get 28071 kilopascal. This option B will be correct for this option B. Now we'll move ahead on the next question. Next question is okay. So the next question is about the number of degree of freedom. Oh, this question is from the GATE 2024, not related to the week number 5. So the number of degree of freedom for natural open channel flow with a mobile bed. It will whether 2, 3, 4, 5. Which option will be correct? So please try to give your answer in the chat box. Degree of freedom I am talking about. So please think on that and try to give your correct answer in the chat box. Such type of question I will discuss in the open channel, that is I think week number 11, or I don't know which week we'll discuss about the open channel, but such type of question I will take care in the open channel part. But here just for we have time 10 minutes more, 10 or 12 minutes, so we'll discuss more questions related to fluid mechanics. So please try to give your answer. Here we are talking about degree of freedom in open channel with a mobile bed. You can, when I will give answer, then I will discuss about the what will be your degree of freedom in different condition, like rigid bed when sediment is not moving, when depth, when your lining only is bank side not the bed. So such type of case we'll discuss here. So I will give you 1-2 minute more for this question, then after I will discuss. Please just rethink and try to give your answer. Okay, and now I want to discuss, please. So here the number of degree of freedom for natural open channel, like river, you can say the actual example, river. So in this river you can think your width is possible to change, slope possible to change, depth possible to change, also river shape possible to change. So here four types of degree of freedom is, that is number of degree of freedom for mobile bed. The correct answer is 4. When just rethink, if your how the width will change, because let's suppose discharge was 1 unit, when the discharge will more from 1 unit to 2 unit, so your area is this much only initially, or let's suppose depth was 1 unit, when you will flow the water more than 1 unit, your depth definitely will change. So like that, definitely is a degree of depth is a degree of freedom. Another, due to the mobile bed or the mobile bank, so what you will think, so this will be change, because your somewhere the erosion possible, somewhere deposition will possible. So your, when let's suppose here the deposition is happening at this place, so what you will, your width at this location will decreases by this much. So what will happen, your width will another degree of freedom. Definitely somewhere erosion and deposition, slope will be the another degree of freedom. Somewhere you have might have seen your river at this location, after a long time, 10 or 12 or 50 years later, maybe your river may be converted like that, not that much, or some branches this side also. So water is flowing like that. So shape also changes. Initially was shape like that, now the shape is very different than previous. So considering these things, your degree of freedom in such kind of channel is 4. Now if I say I want to reduce, or I want to line this bank, I want to line this bank, so what will happen, if you will line this bank, line means what, concreting things, so very less chance to increase the width of the river, very less chance. But still, when you will increase the your discharge, depth will increase. So here depth will be the degree of freedom. Bed is not your line, so your slope also degree of freedom, right? Or whether the shape, yes, if you have already lined, so shape very difficult to change the shape for such kind of river. So degree of freedom might be 2, or just think on that. If you will line the bed also, bank and bed, so definitely slope will not change. Might be possible if water is flowing with a sediment, so might be chance to slope will change. But your water is very clean, what will happen, slope will also not change, width will not also change, only what will change, only depth will change. So in such case your degree of freedom may be 1. So you think on that, how you will incorporate. such kind of cases in degree of freedom. Now the next question, this is the last question for today. Next question is very easy from the kinematic. If flow velocity is given v is equal to 3I 5xj, the in context of fluid of fluid and the flow, which one following statement is correct? Fluid is incompressible and rotational. Fluid is incompressible and irrotational. Fluid is compressible rotational. Fluid is compressible irrotational. So here you need to check rotationality and incompressible, compressible or incompressible. So how you will calculate, please think on that. Within 1 minute, if you are able to give answer, or 2 minutes I will give you. After 2 minutes I will discuss. You have 2 minutes. Yes, slope means wet slope I am talking. That is longitudinal slope of the river bed. So please try to give try to solve this question. Because this is very easy question. Okay. Okay, if okay, you have 1 minute more. You just try to solve, then I will show you. Here you can apply continuity equation or the whatever the rotational equation is given. Actually, I don't know whether I think this part is not covered at in your NPTEL course. Okay, let me show you how you will calculate. So for incompressibility, what you will check whether your delta velocity will be 0. If 0, that definitely it will be incompressible. So del by del x I plus del by del y j plus del by del z k. Into velocity is given your velocity vector here. It is given 3I plus 5xj. So when you will calculate, so I that is this will be 0 and j, so here x is given, so it will be also 0. So it will be 0. So definitely it will be incompressible. Now rotationality check. So here it is just two dimensional, so wz you will check. So v by del x minus del u by del y. So del v by del x means what? 5x. Here you need to put half. So 5x, so you will get 5 minus, because here u is equal to 3 and v is equal to 5x with this, and your u is 3, when you will differentiate with y it will be 0, so your 2.5, so it will be not equal to 0, so your fluid is rotational.